Hello and welcome to this Infinite Runner Engine tutorial. I'm Renaud from Mountains, and today I'm going to talk to you about object pools, a concept that's really at the heart of the Infinite Runner Engine. So one of the main missions of the Infinite Runner Engine is to spawn an infinite, or at least a really large number of objects towards the player or in any direction really. We could of course just instantiate a new object every time we want a new platform. There's one line in Unity to do that. But we'd end up with a lot of objects in our scene. Of course, we could destroy them when they get out of sight, for example, but really the problem is in instantiating the objects at runtime, because it's quite costly in terms of performance, and we'd get a lot of spikes, performance spikes, we'd get freezes, we'd get lag, you'd have a bad experience in your game, so it's really not ideal. And that's where object pools come into play. Right now I'm in the minimal 3D scene, by the way, and as you can see, I have platforms spawning forever. My character is dead, has been dead for a long time now, and as soon as my platforms get past the recycle bounds, so that's the yellow line here, you can see they disappear. And if we look at the profiler, you can see that I don't have any spike. Well, I have one here. What happens? It's a wait for target, so it's not. I mean, it's just Unity waiting for the next frame because it's actually going too fast. But if you look at the rest of the things, the only thing that is costly is waiting for the next. So basically, it's doing nothing, and we are really low in terms of footprint here. We're below the 1000 FPS mark. So why is that? Because we've got a lot of new platforms appearing, disappearing, a lot of stuff happening. But actually, what happens is that I have this object pool here, and as you can see, the same objects get activated and disabled all the time. This pool is not here. If I stop the scene, as you can see, it's not there. So where is it coming from? It's coming from this platform spawner. It's a distance spawner, which means that it spawns objects based on the distance of the previously spawned object, and it's associated to an object pool. So this is a simple object pool. We'll see later on that we also have multiple object pools. This one is filled with 3D platforms, that's the green ones, and it's a 20 object pool, which means that if I press play, at the first frame a new object is created here, and it will contain 20 inactive platforms. So it goes from 0 to 19. We have all 20 objects, and one has already been activated. And if I start going on, you'll see that it goes 1, 2, 3, 4 is activated, 5 is activated, 6 is activated, and now it's gonna, as the 0 has reached the right, it gets disabled and reinstantiated again. It's actually just enabled again. There's no new instantiation. So another thing that is important to understand is that object pools don't do anything on their own. If you just put an object pool in your scene, it will just create the number of objects you've set up, and it won't do anything. You need a spawner to use them, or you can do anything you want with these objects, but by their own they just create a pool and sit there. So if we dive deeper into the code and open our simple object pooler class in MonoDevelop, I'm gonna close the other ones. As you can see, our simple object pooler inherits from object pooler. So this object pooler class is really the base class. You're supposed to extend it into a simple object pooler or a multiple object pooler, and it's really meant to be the interface used by all spawners. It will handle common stuff like singleton and initialization on start. Really do not add this class to a prefab. Nothing would happen, wouldn't work. Instead, you need to add one of its children class, so simple object pooler, multiple object pooler, for example. What does this base class do, and by extension what do all object poolers do. So what it does is that on awake it will fill the object pool, and that's pretty much all there is to it. And there is this method get pooled game object, which is common to all objects. Of course, the way the object pool is filled depends on your object pooler. So in the case of the simple object pooler, for example, we will create a new empty game object that will hold all the instances of the object that we want to create. Then we create a new list, and we add objects to the pool one by one until we reach the pool size. And adding an object to the pool is done like so. We create a new game object, we set it active, we put it into our parent holder object. That's really just to avoid clogging the hierarchy view. We change its name, so we know which one it is. We add a counter to it, and we add it to the pool, and that's really all there is to it. Another thing you want to keep a track of is the pool size. By default it's 20, but really you want to change it depending on your context. So for example, here I have my platform spawner, and if I give it enough time, you'll see that in any situation I can only have a maximum of 1, 2, 3, 4, 5, 6, maybe 7 platforms at the same time in the scene, because it's a distance spawner. My platforms vary in size, but they never get much bigger than this one, for example. So a good solution, because you want to keep performance as low as possible, so having all these objects, in my case, doesn't make any sense. I could have exactly the same thing if I clicked it and said maybe I want only 7, and I don't even want my pool to be able to expand. And considering the speed of my level, the size of my platforms, and the size of my recycle bounds, I should be fine like that. And I think that 7 is the absolute minimum I can have in this configuration. Of course, if I were to have a bigger level, maybe that would become too small. Or even if I moved my platform spawner here, maybe I'd start to create some gaps at some point. Maybe if also I reduced that gap to 0. At some point I'd have my, as you can see, the gap should be 0, but most of the time I have a problem here because my pool is already active. All the objects in my pool are active. So if I were to click pool can expand, as you can see, with these new settings, I need roughly 12 platforms. So a pool size of 12. So that's really something that you need to tweak. Well, you can leave it at 20. If it works, it works. If you want to optimize things, that's something you can tweak. And the best way to do that is just to put a large pool size first. So put 30, press play, see what happens. And for example, here well, of course I need to restart my pool size, and I'm gonna change these two back to what I had before. So yeah, the best way is to just press play and see what happens. So right now I have a pool size of 30. You'll see that it rarely goes beyond 9 in this configuration. So maybe just let your game run for 10 minutes and see where it goes. See if you fill the pool, if you need it to be able to expand or not. Being able to expand, I think I didn't explain that, but what this means is that if I have a pool size of 3 and press play, it will spawn platforms until as long as there are inactive platforms in the pool. So here it spawns 3 of them, they are all active, it cannot spawn more. But if I click on pool can expand, it will automatically instantiate at runtime and at a cost new platforms until it's got enough to continue running. So in this case, I need like something like 11 platforms. It won't instantiate more than it needs, but it will try to instantiate new platforms to avoid creating gaps, to avoid situations where you run out of objects. So really, depending on your situation, you'll want to tweak these two parameters here. Now we've seen how simple object poolers work. Let's have a look at multiple object poolers. One way to see that is to go into the sandbox scene. One of my favorite scenes, and this one contains here, when you open it, maybe this object will be disabled and you'll have maybe the rubber spawner enabled. It's really just a collection of spawners, different ones. You can just disable one and enable that one. So this multiple object pooler comparison object contains a lot of multiple object poolers itself, and the reason why is that there are a lot of settings you can have, and this was the simplest way to give you really an idea of all the things you can achieve using these poolers. So these are poolers that are all filled with the same objects to pool. So we have clouds, rocks, and trees. So the clouds are the white one, the rocks are the small ones, and the trees are these ones. And they all filled in the same order and the same size. So you have in each of these object poolers, you'll have 2 clouds, 4 rocks, 6 trees. The difference is that some of them can expand, some of them can't, and some of them are supposed to be pulled in the original order, and some in original order sequential, some between objects, and some random pool size based. So depending on that, you'll get different results in the way they are pulled. For example, well, this one is random pool size based, so depending on the size of the objects, you'll have every time you try to pull an object, you'll have two chances out of 12 to get a cloud, 4 out of 12 to get a rock, and 6 out of 12, so 1 out of 2 to get a tree. And as you can see, that's pretty much what you get. But really, it might sound complicated. It's not. A multiple object pooler is really just a simple object pooler that can spawn, that will fill the pool with different kind of objects instead of just one. So at its core, if I were to set the size to 1, I have a simple object pooler. That's really all there is. But if I set 3, I can, or 4 or 5, I can drag more objects into the pool here and there, and then I can define the pool size for each one. So it gives me more ways to tweak stuff. And what this will do, of course, will have an impact on, depending on the pooling method I choose. So original order, it will spawn objects in the order that you've set them in the inspector. So let's press play. Here I have 2 clouds, sorry, 4 rocks, 6 trees. 2 clouds, 4 rocks, 6 trees, and here I have 2 clouds, 4 rocks, 6 trees. So really, this will pull them in the original order sequential. I also have original order here, which is a different pooling method. And what this will do is that it will go 1 cloud, 1 rock, 1 tree, 1 cloud, 1 rock, 1 tree, as long as there are objects in the pool to do so. So, for example, the first time it will go, and if I press pause, I should see it. So that's the first one, 1 cloud, 1 rock, 1 tree, 1 cloud, 1 rock, 1 tree. And now we don't have any clouds left because we only had 2. So it goes 1 rock, 1 tree, 1 rock, 1 tree. We don't have any rocks left because we've used them all. And then it's just 2 trees, 2 use the last 2 out of 6. Then we have random between objects. That's this one. And this one, what it will do is that it will pick one object from the pool at random, but really ignoring its pool size. Each object has equal chances to get picked. So if we have 3 objects, a cloud, a rock, a tree, and if the pool can expand, we will have equal chances to have one of these. So if we were to count, and depending on the the direction of the wind, using random, it's always a bit special. We seem to have a bit more rocks, but usually on a large scale, you'd get an equal number of clouds, of trees, and of rocks using this method. And finally, there's random pool size based. That's the one. And this one randomly chooses one object from the pool, but based on its pool size. So the larger the pool size for each object is, the higher the chances to get picked. So for example, here we see that we have much more trees than rocks or clouds, because the pool size for the trees is the bigger. One last thing you can tweak from a multiple object pooler is this checkbox. Can pool same object twice. This can be useful when dealing with, for example, random pool size based. So if I uncheck it, you'll see that we shouldn't see, for example, 2 trees next to each other, or 2 clouds. But if I check it, you see that now I have 2 rocks, 4 trees, because it's random. So there's really 1 chance out of 3 every time to get the same object. I'm really bad at probabilities, but you get the idea. Well, if you uncheck it, you guarantee in most situations that you will never see the same object twice. So now that we've seen how object poolers work, we can have a look at how poolable objects work. So right now I'm in the Backwards Dragon prefab section, decoration, and here I have my clouds and rocks and trees that I was talking about. So they're really simple prefabs. If I drag one into the scene, you'll see what I mean. So here I have a rock complete with its small shadow. So it's got a sprite renderer, but of course you can do that with meshes and whatever. So it's really a Unity object. It has a moving object script. That's not mandatory for poolable objects. It has a poolable object script. That's the important one, complete with lifetime and a renderer. A bounce based on renderer in this case, but it could be collider 2D, renderer, or undefined. I wouldn't recommend using undefined. What this means is that it determines what part of the object it should use to determine if whether or not it's inside or outside the recycle bounds. So if you base it on the renderer, it will take the size of the renderer, and if you base it on either of these colliders, if you have a collider, in this case I don't, it's just a decoration, so I couldn't use the colliders, so it's just the renderer size. And here I have a lifetime, because my objects could be static, not moving, so I could want them to expire after a few seconds. So that's why you define that if you leave it at 0, they live forever. And I have an out of bounds recycle script. That's the script that will allow automatically the fact that the objects will get disabled when they reach the exterior of the bounds. So that's all there is to it. Really, to create a new poolable object, you add at least this script, very probably the out of bounds recycle script, because otherwise you'll have to manage that yourself, and usually you want a moving object. But in terms of priority, you'll need a poolable object, otherwise you won't be able to associate it to an object pool, and then probably these two ones. And then when you're done, you can just drag it into your folder. It will create a prefab. I'm not gonna do it because I already done it for this one, and then you can just drag these here into your simple or multiple object poolers, and press play. And here I'm spawning little village elements, small houses. So that's it. Pretty much everything you need to know about poolable objects and object pools in the Infinite Runner engine. That's maybe a lot of information to process, but once you've gotten a good grasp on this concept, you get the full power of the Infinite Runner engine at your disposal. I hope you learned something new today, and I'll see you next time.